Hello everyone, I'm Donia, a technical application engineer at Strut. In this demonstration, I'll be performing a linear static structure analysis of a landing gear strut using MSC APEX. The objective is to evaluate the structural response of the strut under a landing load and evaluate the resulting stress and displacement. I will begin by importing the strut geometry by here from File and import the geometry. Let's browse it and import. Once the geometry is available, I will generate a 3D solid mesh by selecting the solid mesh in here and keep the mesh size by 0.5 inches and the element type by quadratic element, and just select the model. After generating the mesh, I will quickly inspect it to make sure the elements are properly capturing the overall geometry of the component. After generating the mesh, I can move on to defining the material. We can exit this one and go to the materials and create a material. Let's name it steel and isotropic material, and the elastic modulus will be 30 times 10 power 6 psi. And the Poisson's ratio gonna be 0.3, and that's it. After creating the material, I will define a 3D element property from here, this icon, and create a 3D element property and select the material we just created, the steel one, and then assign 3D element property and click on the model. And you can see here it's assigned. Now the finite element model has both its material and element properties defined, so we can move on to the boundary conditions and loading. The lower cylindrical hole in here, this one, represents the connection between the strut and its supporting structure. So I will constrain this part. You can go here, the constraints, and select constraints. And I'm gonna select the type of a general constraint, and the translation in X, Y, and Z is constraint. And then select this face. You can see it's assigned. Now I apply the landing load from here and assign the pressure to be 532.4 psi. Pressure acting in here, select this one. And with the material support conditions and loading defined, the model is ready for analysis. I will now place the model into the analysis scene. You can go here into studies and right click in here and create a scenario. It's a static one, and we're gonna select the model and the loads. Select the pressure and constraints. We can place it in analysis scene. This performs an analysis readiness check. This allows me to verify that the model has the necessary information and that there are no setup issues before running the solver. Once everything is ready, I can now run the simulation. After the solution is completed, we can move into post-processing. And we can display the stress from here. Just click in here. Here we can see the stress distribution across the strut and identify the regions experiencing the highest stress. I will also look at the translation displacement from this icon to understand how the component deforms under the applied load. Together, these results both the strength and stiffness response of the strut under the defined loading conditions. Whether these results represent an acceptable design would ultimately depend on the actual material strength and the applicable design allowable or safety factor. And we can animate the loads from here and control the speed from here. So this demonstrates how MSC APEX can be used to take a structural component from geometry to a meaningful finite element analysis results within a single workflow. That brings us to the end of this demonstration. I hope this was clear and helpful. For more information, feel free to contact us through the details on the screen. And if you're interested in the MSC APEX student version, please reach out to us by email. And thank you for watching.